Hey kids, this is Mr. Cozy, and this is video 62 where we talk about transforming the graph of sine. The first thing that we need to learn is a faster way of graphing sine. And once we have that down, we'll use it to look at graphs where the amplitude of sine is changed. So yeah, let's get started. When we graphed sine earlier in class, we came up with a very accurate graph of sine. We graphed every angle that we had to know from the unit circle. And for our troubles, we came up with a very accurate graph of sine. On the downside, that took us a while to do, and if we are going to make a lot of graphs of sine over the next few days, so we need a faster way of graphing, and here it is. The first thing that I'm going to do is I have a coordinate plane here. X-axis are the angles from the unit circle. Y-axis is the sine of that angle. If you recall, the period of sine is 360 degrees. It takes 360 degrees for sine to cycle. I'm going to divide that 360 into quarters and have every mark on the x-axis worth a quarter of the period. 90, 180, 270, 360. How far apart you make the marks is up to you. I did every 2 marks. You could do every 3 marks or more if you have the space. I'm just going to do every 2 marks. Okay? Now, on the y-axis, the y-axis is the sine of these angles. The largest value sine could ever be is 1. So I'm going to go 3 blocks up and make that worth 1. And 3 down is -1 because that's the lowest that sine can go. Now, what we're going to do is, instead of graphing all of the points from 0 to 360 from the unit circle, we will just graph these few. And these few will be enough to come up with a sufficiently accurate graph of sine. Here's how. Let's start here at 0 degrees. What's the sine of 0 degrees? And remember that that sine is the y coordinate from the unit circle. So at 0 degrees, what's the y coordinate? It's 0. How about sine of 90? Sine of 90 is 1. Sine of 180 is back to 0. 270 is -1. And 360 is back to 0. And if I smooth this out, I have an accurate enough graph of sine. Okay? Now, I could repeat this whole thought process every time I made a graph, or I could just think about doing a sine dance. And the sine dance repeats where sine is in the middle, where sine is at its high point, and where sine is at its low point. Sine starts out in the middle. Sine of 0 is 0. And then from the middle, At 90, we go up to 1, and then we go back to the middle, and then down to the low point at 270, and then back to the middle. So when you are graphing sine, instead of plugging in angles and figuring out what their sines are, start in the middle, which right now is the x-axis, and go up to sine's maximum value, which is 1, and then go to the middle, and then down to the minimum value, and then to the middle. And if you just repeat this, you'll have a graph of sine. Middle up, middle, then down. Middle up, middle, then down. Middle up, middle, then down. Middle up, middle, then down, and so on. That's the sine dance. So now, if I want to keep this going, I've got to continue the dance. I was at the middle. What comes prior to the middle is down. Then the middle, and then up, and then the middle. So that my entire graph from negative 360 to positive 360 is right here. Middle up, middle then down, middle up, middle then down, middle up, middle then down, and so on. Okay, this is going to be a faster way of graphing sine. Now, with this graph in front of us, let's review what the amplitude of sine is. The amplitude is the distance from the middle of the wave to the high and low points. Okay, and as a default, that amplitude is worth 1. So from the middle, we go up 1, or we go down 1. So sine, as a default, has the amplitude of 1, an amplitude of 1. So how could we change it? We can change the amplitude by multiplying a number with sine of x. For instance, 3 sine of x, or negative 2 sine of x. Each of these changes the amplitude. Okay? The number that we multiply in front of the sine, let's refer to generically as a. And the absolute value of a is going to be the new amplitude of sine. Okay? So what does this mean? Well, let's graph the sine of 3x. Okay? My x-axis, I mark up the same. Every mark is worth a quarter of the period. Oh. Now, on my y-axis, I mark the high and low points of sine. In the previous example, those high and low points were 1 and negative 1. Now, this sine of 3x has an amplitude of 3, so my high and low points are 3. Now, what's nice about this is, in the previous example, I used 3 blocks is worth 1. In this example, I'm using 3 blocks is worth 3, and that's okay. But it makes vital that I label my axes, because you, as the maker of the graph, get to choose what scale you want to use. Okay, so here, 3 blocks is worth 1. I'm sorry, is worth 3. 3 is the high point, and the low point of my graph is -3 because my amplitude is 3. Having these marked up, I just do the sine dance. Middle up is now worth 3. Middle down is now worth -3. Back to the middle. Keep this going on the other side. Then smooth it out. And this is my graph of 3 sine of x. Okay, I know I'm over time, but let's look at -2 sine of x. Okay. X-axis I mark up the same. Every mark is worth a quarter of the period. So 90, 180, 270, 360. 90, 180, 270, 360. Okay, my amplitude is the absolute value of this number out in front. So my amplitude is 2. My high point is at 2. I'm going to make that worth 2 blocks. And my low point is at -2. Okay. Now from here, I just do my sine dance. Middle up, middle down, middle up, middle down. Except there's one little change. This negative out in front is a reflection. Meaning that sine is reflected across the x-axis. If you remember when we did transformations, multiplying a negative out in front reflected things along the x-axis. What this means in terms of the sine dance is if it's a negative out in front, you exchange all of the highs and the lows in your sine dance. So instead of middle up, I'm going to go middle down, middle up, middle. So I'm exchanging all of my high and low points. Okay, this is -2 sine of x. And as a means of comparison, this is just 2 sine of x. Middle up, middle down. This is 2 sine of x. This is -2 sine of x. Okay? So multiplying a number out in front changes my amplitude. It changes what my high and low points are. Making it negative exchanges the high and low points. Okay? Okay, I'm over time, so I'll stop here. Have a great day, and I'll see you later.